The story goes that the famous mathematician René Descartes developed the Cartesian coordinate system while lying in his bed and tracking a fly against the ceiling. Building upon the experience I gained with Unity's line renderer component for freehand drawing in my previous video, I want to continue my goal towards building a system in Unity that can take an equation as input, like x squared plus y squared is equal to 4, and draw it on a Cartesian plane. In this video, we'll be building a Cartesian plane using line renderer and some C# code. Time to have some fun. Let's go over the requirements. We want to draw an x-axis and a y-axis. This will define the Cartesian plane. We also want some tickers on there. So we'll start maybe at -2, -1, then go to 1, and +2. We'll also add tickers to the y-axis. Each game object can have one line renderer added to it. Also, a line renderer is composed out of an array of 3D points. So let's say we had these points defined. The line renderer will draw a line through each of those points. Now, if we wanted to draw an x-axis, you can do that with one game object having one line renderer. However, if you want to now add a bunch of ticks in there, we're gonna run into a problem. So we can go two ways. We can either create a new game object with the line renderer for every single one of these ticks, or we can figure out how to use one line renderer to draw the line and the ticks at the same time. I'm gonna go with option 2 because I think it's more efficient. Go to game object, create empty, and call that Cartesian plane. Then add a component, and we're gonna add a C# script, and we'll call that Cartesian plane. Go ahead and open up that script in Visual Studio. I like to start with baby steps. So let's first figure out how to draw a line between 2 points, and we'll create a method for that so we can reuse it for both the x and the y axes. So we want to create a method, let's call it draw line, and you want to input a name that we can call the game object, a vector 2 for the start point, a vector 2 for the end point. We will send in a color, so we can draw the color for the line and also the line width. Next, we want to create the game object. If you remember, each line renderer needs to exist within a game object, so we'll create that. And then we'll add the line renderer to the game object we just created. Let's add a start world point of type vector3 variable. We'll be taking the start point x and y coordinates and converting them to vector3, and then also converting that from the screen to a world point. Let's do the same for the end world point. We'll also set the start width and the end width of the line to be equal to the line width that we'll be passing in. That's a float. We'll set the line position count to 2, and that will basically be for the start and the end point. We also want to set a line material so that we can add a color to that and control the color of each line. And then this is where we assign the start world and the end world point to those 0 and 1 indexes by using the line.set position. And then finally, we have to return the line because we are returning a line renderer in this function. Add these three class variables. We want to be able to control the axis width, the color of the x-axis, and the color of the y-axis through the editor. So you can add the serialized field attributes to each of these class variables. We now need code to call the drawLine method for both the x and the y-axis. Go ahead and add the following code in the start method. Let's go over this. What we are trying to achieve is the following. Imagine this is the Unity editor screen when you click play. We want to draw an x-axis down the middle over here and the y-axis down the center. To be able to draw the x line, we need the coordinate over here as a start coordinate and the end coordinate over here. So in Unity, the window on the x-axis starts at 0 and it ends on screen.width. To find the y position for the start and the y position for the end point, it's good to find the center point, and we calculate that by creating a vector3 center variable where we divide the screen width by 2 to get this point and the screen height by 2 to get this point. Next, go ahead and set the start and end point using the values we calculated earlier. Also declare a variable called LR of type line renderer. Call the drawLine function, pass in a name for your x-axis, the start, endpoint, the color, and the axis width. And then we're going to set the line renderer that was passed back transform.parent to this transform, and this transform is currently pointing to the Cartesian plane game object. And go ahead and do the same for the y-axis. Let's run this bad boy. We're back in the Unity editor, and if we go and hit play, you will see that nothing shows up. Why is that? Well, we got to set the axis width. Let's set it to 0.01, and the color of the x-axis, let's make that maybe a blue color, and the color of the y-axis, we'll make that a green because that's so beautiful, and hopefully this thing will run. What is wrong? Maybe we set the axis width too small. There we go. So 0.01 was a little too small for the axis width, and 0.1 seems to work pretty well. Now it's time to start working on the more complicated portion, which is drawing the line axes and the tickers at the same time. We will need a helper function where we'll set the line position. It will take in a float x and y coordinate, a line renderer, and an int as the index. We'll create a new vector 3 point, convert that to a world point, set the z of the world point to 0 because we're working in 2D, and then we'll set this line renderer position index to that world point. Add these three class variables. The first one is to determine the number of positive axis units. So imagine we have this x and y axes, if the numpos axis units was set to 2, we'll expect 2 tickers here, 1 for 1 and 2, and we'll duplicate that on the negative side too. The axis tick width is going to be the line width, and the unit font size we'll use later to determine the font size for the labels on the tickers. In the start function, comment out the drawLine calling functions over here, and then set up the calls to the function we're going to be creating called drawAxisUnits. We'll explain these inputs further down. Set up a new function called drawAxisUnits. It will take in a name, the number of positive units, color, the center of vector 3, the screen width, the screen height, line width, the ticker height, and an axis variable of type string. This will either be x and y. We'll be calling this function twice. If we pass an x, we'll draw the x axis. If we pass an y, it will draw the y axis. Next, set up the game object and attach the line renderer to it. We'll call that line. Now we get to this funky little line over here where we're trying to set the position count of the line renderer. And how did I come up with this? Well, it was trial and error, but it kind of makes sense. So here at the end, we always going to multiply by 2 because the number of positive units is only on the right side, so we want to duplicate that to the left. But then how do we come up with this number over here? So let's start drawing that out. We have our y-axis, we have our x-axis, and we have these tickers, okay? So in this case, the number of positive units is 2, okay? So we will also want to draw these on the left-hand side. We'll be drawing these in one swoop using a line renderer. So we'll have to define a point for every single interaction to draw it in one swoop. So first you'll see the number of positive units defined. So that's when we start, right? So if we just counted that in here and we didn't have to go up and down, it will be 1, 2, 3, 4 times 2, so it would be in 4 positions, and we'll have to add 1 for the 0 in the middle. But we also have to go up and down and back to the middle, so that will be, we'll start here and then we'll add 1 point, 2 points, 3 points. That's where this 3 comes, 3 times the number of positive units. Okay, and then you just go to the right again, you click up, you click down, and you continue. Now we're not accounting for the center over here, so this +4 will be going from here to here. 1, 2, 3, 4. Let's set the color of the line. We'll also want to determine the distance between the tickers and the ticker half height. So that will be the distance between the tickers will be this over here, and the ticker half height will be, if this is the ticker full height, the half a height will be from here to here. Let's draw the x-axis. If x is being passed in the axis variable, we'll set the current x coordinate to 0 and we'll declare a current y coordinate. We will loop from 0 to the position count and do the following. We'll call the helper function called setLinePosition, pass in the current x, the center, .y, the line renderer object, and I for the line position count we're in. And this is basically starting on the x-axis at the leftmost point of the screen. So we're starting over here and we just made this point. Then we increment I. We'll go half up a unit tick length above the x-axis. We'll set the current y is equal to the center.y plus the ticker half height. So we'll go here. Then we'll increment I again. Now we'll go down 1 unit ticker line length below the x-axis. So we'll go here. So what we've done now is draw a line from here to here, back down, back up again, and we'll now move to the right using the length of distance between tickers. And what will happen is the line renderer will draw a line over here. We'll just keep repeating this until we get all the way to the end of the screen. And we'll do the same for the y-axis. Let's run this in Unity. Make sure you have your axis width set to 0.1, choose your colors. We can start with the number of positive axis units as 2. Set the axis ticker width to 0.04. The unit font size, we'll get to that later, but for now you can, if it shows up, you can set it to 2.5. Let's click play. And there you go. We have 1, 2 tickers in the positive x-axis that is being duplicated on the left, and it's also being set on the y-axis. And you can actually look at the in 3D view if you wanted to. You can see how that's being drawn. The final part to this is to add the labels for the tickers. Let's add this helper function called place text. And also make sure you call that function by placing it right here. We'll also need to set the unit count. And we can set that right above this whole loop. We're going to have to place it right after we call the place text. We'll also have to define the canvas object, and that we can do as a class variable. And just make sure you have the using text mesh pro declaration here at the top. And we also want to declare the canvas object in the start function, because text mesh pro objects have to be added to a canvas. Let's try it out. There we go. We get our labels working very well. If we wanted to, we can increase the number of positive axis units. Let's set it to 10, for instance. And we run that. You'll see it corresponds correctly.